Hello! Today we're covering the model and some deformation to said model. Now this is to represent the last bar of a robotic arm, one which is meant to be fairly small but heavy duty. That's hence still rather low articulation. This surface right here is less part of the arm and more in place to provide a simulated weight or force for the arm to pick up, as having this surface here neatly simulates having these two clamps grab onto something. Some nice rounded edges here to reduce the stress from edge concentration. We have here a circular hole in which a motor would be placed. Thus, it'll just be bounded as non-moving to represent the rest of the arm. And the arm has these 4 holes through it, barring the circle, as having a completely solid bar would both be rather wasteful in terms of material, and would leave no room for the wires or motors for these clamps to exist. Moving on to the damage, here we have the total deformation. As you can see, there's kind of a decent bit of it. It's not terrible, but it's definitely something like we see happening all the time. However, this is with a 5,000 Newton force on that small little bar right here, so it's fairly understandable. In addition, we have the von Mises stress here. So you can see, even though it's bending fairly heavily, nothing is being pushed past the point of breaking. Terrible. If there's any red in here, it's only in tiny specks. And finally, as my project is on fatigue stress analysis, here we can see the life of the various areas, such as how, after only 624 cycles, the power would start to fail. Notably here are the clamps, which is to be expected, but also here, and on the reverse side here, wherein the rest of the robotic arm would connect. In addition, there is gravity simulated for all of this, just for the record. Thank you for your time.